So thank you. Thank you for sticking around to the end of our conference. And I'm going to tell you a little bit about really an approach to data collection that I really like, that's actually, I think, arguably fun, and could be very useful. A useful approach both for researchers and actually for practitioners and even communities for collecting data about the built environment, about travel behavior. And that's mobile and wearable sensing. And you know, I just have this painting of Thomas Jefferson in here because, you know, that's what we're supposed to be doing, Cody. So that was for you. Yeah, exactly. But of course, he is the person who said you should walk or at least have physical activity, I think, 2 hours a day or something like that. So he said everything, but that's painted on the side of our gym, as you might imagine. So, you know, there's quotations from Thomas Jefferson everywhere around here. So let's see, by show of wrists, how many people have a Fitbit on right now? 3, okay. Oh, it's in my bag. It's in your bag, okay. All right, so 3 wearing, 5 have one. Do you all have one or no? Okay. Oh, see, you're not part of this. Well, a lot of people wear Fitbits today. It's a thing, right? Now, how many of you have done this? Worn, yeah, Fitbits, GPS watches, trackers, all of that at the same time? No, most of you haven't, but in a way, this is kind of leading. This is what I am hoping people might do in some ways. So this is the idea. Can we have a Fitbit for streets and cities, for mobility, for the environment? So this is really, there's 2 things I want to talk about, and you know, we'll take as much time as we need to for it, but monitoring transportation networks and travel behavior, I think, can be informed by wearable mobile sensors, and so that's really our subject matter for today. And there's 2 ways I want to talk about that. First of all, what are the specific issues in transportation sustainability that we might address? And then how would we do it? What are the methods around that? And so, you know, this I constructed, you know, to kind of take as much time as we thought we might want to take. But hypothetically, this is what I'd like to do is go through and think about the context for all of this within the kind of the wider realm of data and the Internet of Things that we hear about so often. Where does this fit in with all of that? Then, if we take a break, then there was an app that the reason I selected it is because it actually works on both iPhone and Android, which is fairly rare in this world so far, to have something that works universally. So we might try that out. And then I wanted to talk about the method. And so I'm going to base it on some work that I've been doing, some research I've been doing, but I think it's applicable and it'd be interesting to hear how it, you know, how it sounds to you and how you might think it might be applied to other situations beyond the one that I'm going to talk about. So the context for wearable sensing, wearable mobile sensing, is of course a data context. We have tremendous data needs in transportation planning, transportation engineering operations. These data needs are large, and we have an increasing amount of data available to us. Certainly, emerging sensing technologies fall into a lot of buzzwords. The Internet of Things, the idea that we're going to build sensors into everything. This building, I don't know if it's been mentioned yet, but this building is filled with sensors, if that's correct. Keeps it nice and cool. Exactly, they're working so well. But this is a sensible building or a sensing building. And obviously, we're trying to do the same thing. You saw so many posters out there earlier in this conference talking about different ways of collecting data. And so this falls into that. I think that the word crowdsourcing also gets thrown around a lot. I'm going to use that word crowdsourcing. I think there's an interesting challenge with who the crowd is and getting them to contribute data that this rides right along the edge of. So we'll talk about this idea, and can we turn something that requires a real investment of time, potentially, and then an investment of actual cognitive power to figure out how to do all of this, can we turn that into something that's maybe easier to do? But then at the same time, can we make this something that is a contribution to a community-based planning approach, a community-based design approach? So those are some of the questions that I think we need to think about with this, but with a lot of the data we're collecting anyway. So fundamentally, this is about data at the intersection of environment and behavior. So I think it has a lot of applications then for sustainable transportation. The kinds of data that I think we can collect with these Fitbits that face outwards rather than measure our own health, certainly mobility data, and actually we already saw that. We saw that there was a poster that talked about how you can use a smartphone to track diversions around crashes, incidents, things like that in the Hampton Roads area, but also outcomes data. So by collecting information not just about our mobility patterns, but at the same time collecting information about outcomes, about what is around us, whether it's emissions, whether it's noise, whether it's the presence of nature, whether it's the presence of businesses, we begin to be able to understand how our mobility patterns are related to outcomes, whether they're health outcomes or economic outcomes, a number of different kinds of outcomes. So we already have data. We have a lot of data. And that's important to remember. We have readily available data from traffic monitoring. We have travel survey data. We have the census. We have lots of land use data. We have some air quality monitoring from stations. And we have all kinds of government records. And people I've talked to in computer science, for example, are trying to use those existing sources better than we are today. I mean, content analysis, data mining, all of those, again, kind of jargony terms are things that are being applied to all of these secondary data sources. And what I'm talking about doesn't contradict that. I think it could all work together, actually. But there are drawbacks to this secondary data. Of course, something like a census is very infrequently taken. Our travel surveys are very infrequently done. There's spotty coverage. So even when we have an air quality monitoring station, so far, we're going to talk about where this is all headed, and not just with wearable sensing. We really don't have the resolution of data that we need to understand some of the impacts, and I'll show that in a second. Even when we have a good data stream, oftentimes what's available even to researchers without a lot of difficulty, and certainly to the public, is highly aggregated, or there's significant usage restrictions. So we'll talk about privacy, if we want to, a little bit. And then, of course, there's just high institutional costs. So one of the things that I'm thinking about is how we can lower those costs. And I think because of those kinds of drawbacks, we can't answer a number of very important sustainability questions. So what are some of those questions? What are the questions that matter that these kind of data, sensor data generally, but then maybe mobile wearable sensor data might specifically address? Well, there's the issue we have that a lot of the pollutants that actually matter on our streets are actually this is what happens when you're at the end of a long week, but they have high decay rates. I think that's what I was trying to say. And so what we find is that there's not some kind of distribution across the entire region, as we often talk about with pollution analysis, but in fact, being 5 meters away from a freeway is very different than being 300 meters away from a freeway. So we might want to be able to see that, because if you're walking in a neighborhood, it matters if you're 5 meters away or 300 meters away. Well, we typically have not had data like that available. Certainly not in an extensive non-atmospheric research context. Then we have the issue of the interplay of modes. So what happens when you're in a car versus when you're on a bike or walking? And this is a terrible table to show you, but suffice to say it shows that being in vehicle versus out of vehicle, this all matters. And so we might want to measure that and be able and make it possible for anyone to measure that. But it's not just about pollution. I think that, again, when we think about sustainability broadly, here in Charlottesville, we have a big issue with what happens to young people at night. And lighting and safety is a big issue with that. So we don't really have, we have maps of streetlights, but we don't really know how that light is actually scattered around neighborhoods. How do people's trips at night interact with nighttime lighting might be a question that this could answer. And like I talked about multimodal infrastructure, those juxtapositions, again, how do they work? And not just the juxtapositions of cars, highways, bikes, walking, things like that, but also just the quality of our infrastructure. Could we use sensing, especially mobile sensing, at the level of a human as probe, really, to be able to answer some of these questions? And if we wanted to do that, how would we go about doing that? I think finally, especially in international context, and we'll talk about, you know, the future of fixed sensors, but I think that in an international context, to be able to have sensors everywhere you are may be very advantageous, rather than to think about, well, hopefully if we get $100 million, we can network out the entire New Delhi region, for example. Is that going to happen anytime soon? It might, I don't know, but I think that in the meantime, having all of our sensors with us wherever we go could be very useful for understanding all of the conflicts that we see on this street, all of the environmental, mobility, accessibility types of conflicts that we might be interested in. So, like I said, there is a important caveat here, which is that there's other ways of doing all of this. This is just one thing. And so, this is an example. Has anyone heard of the Array of Things? No, it's in Chicago. A group of big universities and players in the industry got a grant from the NSF to install smart lampposts all through downtown Chicago. And now, it's funny because if you talk to some of the people that I work with who are building mobile sensors, they're really annoyed about this because the grant was received about 3 years ago and there's still no lampposts operating. And so the guy who built this pollution sensor said, I could have given them 1,000 of those, 2 years ago. So that's kind of interesting. But this is a fixed set of sensors that measures environmental, that measures things like temperature, humidity, air pressure, air quality. So again, some of the things that I was talking about as well, light levels, and it also functions as a Wi-Fi terminal. And I think it's important to say that Google is in on this. Has anyone heard of Sidewalk Labs? You've heard of Sidewalk Labs? Yeah, so they're out in New York City. I'm not sure whether these are on the street yet or not. Does anyone know? Yeah? They're in the subway. Okay. Supposedly, their gift to the city of New York is that they provide free Wi-Fi, but they also are all supposed to have the same types of sensors built into them. So that's important, and that's an approach. And I think a lot of the people who work in this field are talking about installing sensors in bridges, installing sensors in roadways, to monitor the infrastructure. So I think the idea of putting sensors into things that are fixed is exploding and is growing. And so we have questions about what kinds of sensors we should put where, and can we put enough sensors to actually get the coverage we need to answer some of the questions we have, especially with complex patterns of mobility that impacts may vary from 1 meter to the next. Well, I hope they don't vary from 1 meter to the next, because I don't have that kind of resolution. But anyway, that's fine. Now, I think there's important things to consider. Again, like I said, what are the contexts? Could we ever get sensors everywhere we want them to be in a fixed sort of way? Because if you think about what I'm describing, we could all track our behavior with smartphones or different kinds of GPS wristbands and then collect data about the environment through fixed sensing. That actually is another way of doing all of this. I haven't even shown you what I think we should be doing or we could be doing, but I think that it's important to say that, well, that's not necessarily going to work in all contexts. It won't work in parks. Is it going to work in the suburbs? Is it going to work Maybe it will in the long run. Maybe this is an intermediary solution. I don't know the answer to that. So I think it's important to say it's a lot of what I'm talking about and a lot of the work that I do focuses on walking and biking in the context of a multimodal environment. But at the same time, there's no reason we couldn't add to the array of sensors that's already in a new vehicle and measure what's going on around us. Now, so this is, again, kind of the set of sensors that might be used to make an autonomous or automated? Thank you. Autonomous vehicle actually function. Could we add sensors about what's around us to that? We could, possibly, and there's no reason to think we can't or shouldn't do that. So the other thing that I said I wanted to talk about for context setting is crowdsourcing. And so for crowdsourcing, this is much bigger than sensing. Crowdsourcing could be asking people questions. It could be asking people to contribute to goals for a long-range transportation plan at an MPO, for example. And this is from a paper in the Transportation Research Record from a couple of years ago that really does a nice job of talking about all the different kinds of crowdsourcing. And to some degree, the type of sensing that I'm thinking about really falls into this kind of down at the bottom, same place, different time kind of sensing. Maybe different place, different time. But the idea of being able to map people's routes, for example, is just the beginning of all of it. But again, that's kind of where it falls in. There's a lot of different kinds of crowdsourcing that exist. Now, what's important is that there's a lot of problems with crowdsourcing. And all of those things, in as much as what we're talking about here is a form of crowdsourcing, getting people to actually contribute to a data collection process, we're going to face all of those same problems. So it's great that we can get the wisdom of the crowd, so to speak, even if it's just their behavior or where they've been. But how do you get the people to actually do it? How do you actually know whether the users are doing it right? Then you have to aggregate the information and do it in a way that's intelligent. And to some degree, you have to be able to evaluate, and I said evaluating the contributions of users, but it's about how do you actually then provide some kind of return, some kind of benefit to the users who participate. And those are all really important questions. So in terms of crowdsourcing examples, some are more famous than others that have already happened. The city bike stations, so the bike sharing in New York City, the original approach to locating stations, the bike stations, was done through a crowdsourcing process where people made suggestions and then they aggregated the suggestions. So that was all an online process. It was not done through an app. It wasn't done through GPS. It was just an online process. The only other one I'll show you, because there's a million of them, it's almost a random selection here. One that maybe approaches what I'm thinking about a little more closely is this one in Atlanta called Cycle Atlanta, where basically a bunch of cyclists have agreed to provide their tracks. And you know, they can enter in what kind of ride they've been taking. Oh wait, you don't see any of this. Sorry about that. Hold on. That's right, I will go off of present mode for a second and go on to, there we go. Go onto this map, and you can see they've made a nice interface that shows the aggregation of routes. So that's pretty cool. I mean, that's the beginning of this, and we can understand implicitly how we would use this. These are origins and destinations. We could use this to create a transportation model, a model of cycling demand. Yeah, Cody.
So they just have their phones on and they're tracking their GPS?
Yeah, they just, you know, they contribute to it, and I think there's an app. I think they have a purpose-built app that automatically uploads it and all of that to the server. But yeah, and then this is very useful information for making planning decisions. And this is just routes again. I think one of the most important things that I want to come back to is that we're already doing this with just GPS traces. We can learn a lot from just GPS traces, And actually, let's move on to the next slide. Even more than that, transformation, I believe, transformation modeling has already been transformed by just the fact that we have these call data records that even without having precise GPS information, we can analyze these moves from cell tower to cell tower that everybody makes and translate this into traffic data, speeds on roads, things like that. And this is going on all the time. This is from an engineering firm that uses these kinds of data. This is completely out in practice already. We can use it for planning as well. So again, this is an example of every taxi in New York City has a GPS built into it. They could use that to determine what happened when they closed Times Square to traffic, what happened to traffic speeds all around. So this is known. This has been done all the time. I think that in terms of crowdsourcing, there's a lot of other windows opening. And in some ways, I just want to make sure we're aware of all of that. This is content analysis. These are Yelp reviews that either mention parking or rail. This is Phoenix. And it shows that, in fact, people, when they talk about how they got to a restaurant, they're talking about the geography of the transportation system at a level of refinement that's far greater than what you might get in a travel survey in terms of the number of data points. And so we can really see where people are using, at least for commercial destinations, where they are using different modes. So there are a lot of different ways we can do this. But I think that there's still room to think about collecting our own data actively rather than passively, or using secondary data sources. And so this, you know what? I think, shall we just not take a break but just talk about this, and we'll learn this? And this is how I hope you leave today. I'll come back to this slide. You leave today downloading NoiseTube and trying it out, because that's an app that everyone can use to try to think about all of this. But basically, I think what we should do, since I don't know what time it is, but we're going very fast, is actually go past our break time, just take another half hour or so and talk about the doing of all of this, and then go for a walk. Use NoiseTube while you're going for a walk and seeing what you think of the experience, the very kind of rudimentary experience of collecting data with your phone. So we've actually gone through part one, and part two is talking about, okay, all right, I've kind of set a context, hopefully, but now how do we do this stuff? How do we actually use mobile wearable sensing to understand environment and behavior issues? So I think, like I said, just to hammer it in, the interesting thing about mobile wearable sensing is you're both monitoring behavior patterns, you're seeing where people are going and how fast they're getting there, but you're also collecting information about where they were. So that's fairly novel. I don't think there's really any other way to do that. Now, of course, with fixed sensors, you can aggregate data from fixed sensors with patterns, but I've heard it argued that it's not seeing what you're seeing, it's a different angle, it's not necessarily actually reflecting what a human being is actually experiencing. Now, I think it's important to say, I'm talking a lot, again, about the kinds of transportation and the kinds of things we can measure when we are a human on the street, not when we are inside of a vehicle. That's actually true and not true at the same time. One of the big challenges of this is actually being able to measure our experiences in multiple environments. So one of the big challenges that I've had is how do you actually move from like an outdoor space into an indoor space and continue to collect data? Because right now, a lot of GPS doesn't work indoors. There's other methods of collecting positions indoors. But what happens if you walk into a mall? How do you reflect the fact that you've moved into a new environment? That's actually very hard to capture. And I think the same kinds of things would hold for being inside of a transit, being inside of a subway station, actually, for that matter, or anywhere else. Now, the thing that we do get with GPS, at least, is very high space and time resolution. The idea here is to use the person as a probe, basically. And like I said, I actually said this, it's a natural fit with walking and biking. Actually, I covered that already. I anticipated myself. I do think it is transferable to vehicles and multimodal situations as well. Now, the analysis in general that I think we can do is based on individual streams, the mobility stream, or the environment stream, or both. And that helps us answer different kinds of questions. Of course, a very basic question is how much do we walk? And there's still a lot of question about how much we walk. And there's a lot of research going on, including at MATS UTC, about better methods for counting pedestrians and bicyclists. Well, this could certainly contribute to that. And then there are other questions we have about how polluted are our streets? Or how do they affect us? That's a whole separate set of questions. These data could actually bring the two together and say, how much pollution do we inhale when we walk, for example? So I said there was kind of one more kind of flavor to all of this that I think is important to remember, is that we can use this as researchers as, you know, a novel way of collecting data. But this process also, I think, even compared to fixed sensors, has a potential to be more community-based, to actually engage people in the process of collecting data about their own lives and about the communities they live in. Because anybody can choose to do this. They don't rely on, for example, Google or a large NSF grant to install an array of sensors. Of course, we can have open data and make data available, but there is something, especially in our era where tactical approaches to changing our environment, changing our cities, like tactical urbanism, exists, where if we can collect our own data and get the data ourselves, that may actually be a very enticing, very democratic way of doing things. But of course, that means we need to pay attention to some other parameters when we're developing these systems. They need to be lower cost. We need to figure out ways to get the participants involved. We need to think about the complexity of the system and is it usable? And we need to think again about the ownership of the process. Who owns the data? Who owns the method? Who owns the results? And that's actually really, really important. Now, I think that ultimately, it's very important to remember that different questions, different analytic questions that use new data sets, that use data, some are going to keep using survey data, some are going to use traditional secondary data, our loop detectors, our surveys, our census. That will continue to be how we answer the questions. Some things will actually be able to use new secondary data, like Twitter. You know, we've seen amazing things analyzed through Twitter data feeds, or the Yelp data, for example, that I showed you. Remote sensing, so satellite data, is very important. And actually what I'm really excited about is that in the long run, some of the methods we use for remote sensing could possibly be applied to, and this is a research question, not an application issue right now, could possibly be applied to mobile wearable sensing as well. But that's for another time, potentially. And then, of course, fixed sensor data, and then finally our mobile data. So I think the best framing, I started this way, but I just want to kind of bring it back to you again. I think the approach from the health sciences is really useful here. It's not a one-to-one kind of application, but this idea of self-metrication, measurement of self, that lives are comprised of data points that get everyone really excited, or at least some people excited about wearing a Fitbit, could be applied to cities as well. Know your city, know where you are, know what's happening to you when you go for a run, know what's happening to you when you go shopping. Those sorts of questions, we could frame it that way, and we can see if people really buy into that or not. And I think there's evidence that they could. And it does establish a nexus, a logical nexus, a connection between personal health, your own health, and the health of the city, the health of the street, the health of the environment. So as I said, now I'm not talking about some kind of broader concept of ownership, but I'm talking about how do we actually do this, who builds sensors? So this has been challenge number one. So now I want us to talk about how we do this. And it's been really fascinating. So if we're going to have a system that's usable and low cost, we need to find different types of sensors from different providers, at least potentially. And some of them, your smartphone mostly, come from some of the largest, in fact, the largest company by capitalization in the world. So that's kind of interesting. So your iPhone, that's an important part of all of this. But then other sensors that I'm using, so here's something that these people are wearing called an air beam. And it measures particulate matter, and you can just clip it kind of on your belt or something like that. And it measures PM 2.5 micron size particulate matter, which in terms of mobile source air toxics is a major concern and is associated with pollution, is associated with asthma, is associated with cancer and a lot of negative outcomes. And this is the kind of thing that has a very fine scale of emissions. This device is sold by an environmental justice organization in Brooklyn. So it's a real range. And believe me, when you're looking for the right sensor for the job, it's not easy. Sometimes that makes me wish I was in an engineering school so that I could talk to the electrical engineer down the street, down the hallway, and say, can you build me something that I need? So I'm learning to build things on my own. But I think that it is really fascinating that it is that much of a breadth. And in fact, sometimes, especially when you're getting things from small groups, they disappear. So if you want a set of sensors, but you're not building it yourself, there are a couple of devices that I've used that the company that makes them, or the group of hacktivists that make them, to use another jargon term, they're gone. So I can't replace them if I want to use them for my next outing. So this is a typical kind of designed process. You start by identifying your issue. You identify your data needs. You identify how you're going to get your data. You establish protocols for collecting your data. You actually collect the data. You analyze it. And then hopefully you use that analysis to actually inform the issue that you cared about in the first place. So this is very standard. I want to just show you how I've done that with an example that is in process right now in Tyson's. People call it Tyson's Corner. The people who used to call it Tyson's Corner want to change the name to just Tyson's or Tyson's City because they don't want people to think of it as an old rural corner with shopping malls anymore. Now it's, or suburban place, it's now an urban place. So this is where I'm doing a lot of the work that I do in this area because I think it's very interesting. This is a place, well, by show of hands, who's been to Tyson's? Okay, about half of you, sort of, okay. All right, well, we're not that far. So anyone heading north after this? Let's see. All right, you should stop at Tyson's Corner. Yeah, check it out. There's a Shake Shack there. So I think that, in the mall, but yeah. And the Tesla store. But I think that place is interesting because it's a major planning. It's a site of major planned transformation, and the idea is to turn something that is very suburban, I'm going to skip ahead to the pictures. I should have put these first. To turn something that looks like this, which is very suburban, which is just a bunch of office parks and shopping malls, into something that looks more like this, which I know doesn't look that different, but is comprised not just of commercial development, but housing, commercial development, a major transit system. So the DC Metro Rail now goes out to Tyson's Corner. And the idea is that you don't have to drive there anymore. The idea is that you can walk and bike when you go to Tyson's. You can take transit, get out of the metro and walk and bike around. Or you can live there and walk and bike around. So my question as a transportation planner is it working? Is this actually happening? Are these changes to land use and to infrastructure really causing change? So here's a few maps. Tyson's is actually on the Silver Line. So you can see how the Silver Line moves west from central DC. Here's a map of the infrastructure with several metro stops. And then to go along with the metro, the idea is that almost every parcel in Tyson's is going to be completely redeveloped. They've lifted all density restrictions around transit stations. So you can have, in Northern Virginia, this is kind of amazing, 20, 30, 40-story buildings, no limits on heights, around the metro stations. And they can be apartments, they can be office buildings, and it's all supposed to be linked by pedestrian paths. So the formerly highly auto-oriented network that you see to the left is supposed to transform into an almost, not just almost, but supposedly a very urban network. And so that's the idea. And so what I want to do is understand whether that's actually happening and what it actually is like to be somebody walking or biking in Tyson's. So when you add it all up, is this working? And so these are really classic transportation planning research questions. And can we measure whether it's working not just in terms of behavior, but in terms of the experiences of people on the street there? So this is a messy table to put into a PowerPoint, but just focus on the left side, actually. We can ignore the right side, especially for now. We'll come back to this table. But so essentially, my research question is around walkability to a great degree. And there are a lot of mobility and environmental factors that determine whether a street is walkable. The presence of other walkers. Are there actually other people walking? That matters. People don't want to be alone when they're walking around. Is it safe and secure? Is it noisy? Is the air quality good or bad? How easy is it to get around? Do you have connectivity, for example? Is it hot? Is there a lot of glare? How does it feel to be there? And then you can see at the bottom some meta measurements. So comfort being one of them, the presence of nature. As we move into sustainability and health being kind of aligned with one another, well-being is highly tied to the presence of nature. And so kind of a funny thing is that suburban environments have a lot more nature than urban environments, but we'll leave that aside for now. And then accessibility. How do we measure whether there are places to go? Well, there may be some ways to do this with mobile wearable sensors. There may be also secondary data sources and other data sources that could be used as well. But essentially, this is the initiative to, over the long run, create a vector of travel and environment data at the point of an individual, at a location and time, that then you collect across many, many different variables. And you build that up and you use that for analysis. And again, this idea is certainly from a research perspective, we might have a complex, robust stream of data coming in. For somebody in the community, you might only really need a very narrow band, and maybe that's okay. So there's been some news about what I'm doing that made it into the press in Washington, D.C., and after that came out, I got a phone call from the school district in Fairfax County. And it was somebody in their Safe Routes to School program asking about how they could do this to measure pollution idling at drop-offs for school, at school locations. And that's a very small question, a narrow question. And they wanted to know what kinds of sensors they needed to use and all of that. So this could be very thin and very fine if that's what you want, or it could be very broad, very, research, I want to understand everything about these environments, which is what I like to do. But I think that with wearable sensors, if you have a kit, you might be able to apply any set of measurements. And so what do we need? Well, we need a bunch of things. We need air beams to measure air quality. Our smartphones have microphones, and actually they've been rated by by groups like the NIH and things like that as to how accurate they are and all of that. But it helps to actually have like a lavalier mic that you can plug into your smartphone to get more accurate noise data. All of these things. Oh, this costs $250. That's actually really good. And the This is the air sensor. And it has been rated by any air quality people in the room? The Southern California Air District, whatever their actual name is. They've actually rated it and said it's good, it works. It's a lot cheaper than what you could probably get 5 years ago. This costs about $20 to plug into your smartphone. A smartphone, either you have one or you can get one cheap, depending on the plan and depending on the smartphone. And so there are a number of, I just want to talk a little bit about a number of the different kinds of devices and data streams. And really, again, if you're building a protocol, the kinds of things that you have to pay attention to. And I think, especially, as an engineer, you know that these are all, some of you are planners, some of you are engineers, but you know that all of these things matter a lot. I'm going to go quickly through all of this. But I think that, again, think about how you make this usable, not just in a research context, but in a practice context as well. And I think that actually makes things a little bit more difficult to find that perfect eye through the needle sort of approach. So tracking in GPS, I think all of our smartphones do this already, and we use those data. But at the same time, I found that they're not always as accurate and reliable as maybe having, a Garmin on your wrist or something like that. And so in my protocol, I have a wristband that tracks GPS, and I found that to be, it's not actually so much about the precision, it's about the accuracy, it's about the reliability, that they fail less often. Because smartphones, they end up in a pocket. You can't ask somebody to, well, you can ask somebody to do this, but I don't think that works so well. So again, that's a problem. And in fact, there's data on this. You can go to the NCHRP report on using GPS to get data on getting reliable, accurate GPS information. Now, air quality, we talked about that already. There's a lot of different emissions that we might measure. I think PM, especially particulate matter, PM 2.5, everyone's kind of got their eye on this. Often when they talk about pollution levels in Beijing, for example, or in New Delhi, it's often PM 2.5 measures. It's very deadly. And it's very, like I said, the spatial gradient is very steep. So I think that means that high resolution is useful, like we get from a system like this. Now, of course, again, if you're going to do this, you need a lot of repeated measures because the wind blows and the number is different. So you need to be able to actually repeat this over and over again. That means it's crowdsourcing. That means you need a lot of inputs. It also means, oh no, we need a lot of inputs to get a good answer. And so these are some of the challenges. Noise, I talked about that already. This was a piece of advice I got from an environmental justice activist who said, yeah, nobody wants to hold their smartphone in their hand while they're walking around. Get this and, plug it into the smartphone jack and then clip it on somewhere. So that's just, practical sorts of things. Temperature is really important. One of the things you find when you study walkability is that highly concretized asphalted places are very hot and uncomfortable, especially in the summer. They might be better in the wintertime for that matter, but you need relative temperatures. So you need to get National Weather Service data, you need to compare to an average measurement for your particular area. So those are some of the challenges of doing all of this. That just mean there's a high, this is a data project. Optical, so taking pictures. What's funny is not everyone, how many people have a GoPro? No, you have a GoPro? What do you use it for?
Not much, but
Riding your bike around. Yeah, exactly. Did you say you have a GoPro? You haven't used it. That's like me. Yeah, exactly. Although I'm using it for this now. Every image you take has a lot of data in it. Now, as it turns out, and this is what I'm learning again, talking to a lot of people who do image processing and optical analysis, is that a red, green, and blue channel can tell you some things, but they can only tell you so much. So I guess one thing about the application is, wearable cameras looped around maybe a backpack strap or around your neck, they work and they give you a view that you experience as a walker or a biker, and that's what a GoPro does. That's what a wearable camera, which, oh, mine is out in the field right now, but that's what a camera like that one would do. You know, Google Glasses was kind of exciting while it lasted. I guess it's coming back in some form or another eventually, but that way it's much easier to take those kinds of pictures. But what can you do with it? Well, the answer is right now, image processing is a very emergent field. I don't know if any of you are in image processing, but it's actually been shown, interestingly enough, that the green channel in a picture is highly correlated with trees and grass. So that's nice. So you can actually get a measure of nature. And at least it's been published in, you know, in high impact factor journals that this works. You know, even a 640 by 400 pixel image of a tree, it'll tell you if there's leaves on it or not by looking at the green channel level. And so we could do that. We can do that, and in fact, I have done that. But at the same time, wouldn't it be nice eventually to understand, are there people in the picture? Are there actual trees in the picture? There is a possibility of doing that, but not right now. There are companies out there like Placemeter, for example, that use video to count, you know, through processing, not just manual counting. But we're not there yet. So that's interesting. Another important part of all of this is that it's not just about the world as we measure it objectively, but it's the world as we perceive it. So this is a high hurdle in the sense that our perceptions of pollution, our perceptions of noise, our perceptions of whether we like where we are you happy, are you relaxed? This is from an app called Mappiness that's primarily in the UK, for example, that prompts you wherever you are to like say, how you feeling? You know, and then it geolocates your emotional state, basically. This actually, the disconnect between how you feel and the reality, or whether you think it's safe and whether it is safe, is a big, big research question. And this is part of the protocol, so to speak. But it's also hard to do because how do you get people to answer that? Answer it in a way that, you know, in transportation, we have problems with stated preference and revealed preference anyway. But maybe in situ, when somebody's in the moment, we can ask them a question and hope we're getting a fairly accurate answer of how they feel. But then you have to bug them, and suddenly you've taken them out of kind of their environment, their psychology for the moment. So that's a real challenge, but it's actually something that people on the engineering side here at UVA are doing as well. And so we're collaborating on how we might develop this environment perception connection in this tool. And then I think there's the future, the emerging area. And this is something that's been done in a fixed way, but we can do this actually fairly easily without much difficulty in somebody's backpack or in their pocket, is actually count the number of smartphones and how far they are away from you while you're walking. So you can't count people like this, but with Wi-Fi signals, Bluetooth is kind of fading as a good way of counting, but Wi-Fi is still good. Wi-Fi pings, Wi-Fi broadcasts. We can count the number of Wi-Fi signals, and actually, therefore, it has to be validated with how many people does that actually count as, and are they in a car, and are they walking? But this, again, is an interesting emergent area that I would like to take advantage of. I would really like to be able to take advantage of this. So, this all amounts to an idea that we need to make this stuff easy to do as much as it has to be valuable data, because otherwise we're not going to get a community of people to do it. And I think some things, keeping a smartphone in your pocket, that's easy. Doesn't mean people will do it, but it's not hard to do. If you start an app and let it run and it's in your pocket, that's not so much of a burden. Wearing a wristband, oh yeah, I mean, yeah, it's harder than you might think. On a smartphone? Yeah. Yeah, that's true, actually. If you're running an app the whole time, you're right. Especially if it's your GPS, which is another reason why a wrist GPS, And today, Fitbits are starting to have GPS. I mean, the high-end Fitbits are starting to have GPSs in them. But then Garmin there are companies that make wrist GPSs. So that's what I'm using for now, and that's easy. That works. I mean, that works. Pollution monitors, these are not hard to use, really. You just turn them on, and they record. So, and what I do is, well, I'll talk about data processing here in a second, but then you have to obviously geolocate everything you collect. And there's multiple ways to do that. The microphone, again, if the smartphone is in your pocket and you're just running a sound app, and this is just kind of hanging out of your pocket or something like that, that's not terrible. But then, wearable cameras, you're starting to ask people to like have something hanging around their neck. It starts to get a little complicated, and it has to be facing forward. These things are getting a little more challenging. Anytime you ask anybody to hold a device in their hand to do this, it's suddenly becoming a burden. It's truly becoming a burden. And then anytime you ask them to actually enter data, so all of those perception apps, for example, it's hard to do that all of a sudden. Yeah, Leia.
You could just get Pokemon Go in on it.
Thank you for bringing up Pokemon Go. Exactly.
It hasn't happened in 2 days, but I was like, come on, guys.
Yeah, I mean, we don't have time to talk about it. That could be a whole segment of this, actually, is Pokemon Go. But does anyone have Pokemon Go, or is that you're not allowed to admit to it? You played around with it? I think what it teaches is because, so again, healthy mobility planners have been thinking about gamification for years. Who knew that the answer was actually just to make a game? Like, not to make it about, oh, how fun it would be to get exercise points, although the Fitbit kind of does that. But just have a game and make it a good game? It's a good game? I guess so. I think that's really fascinating. But I think that, so this friction of usage is really important. And I think this is where engineering and not, the models is part of it, but the devices themselves. We have Apple, we have hacktivists. We need more work in this area if it's going to really be a successful thing to make devices low cost but usable. And I think it's part of our new world of makerspaces and part of our world of using Arduinos and Raspberry Pis and all of that. Are you pointing at somebody? Oh, Emily, I just haven't looked at, yeah.
Sorry.
Yeah.
So maybe like the Pokemon Go, because I'm sitting here going, but like, why couldn't like we, try to figure out how those people could do some of our walkability, measuring for us or something? I mean, like.
That's a great idea.
We could be discussing, or like that would be like a good small group if that works discussion, or a larger discussion if that works at some point.
That's a great idea.
Yeah, so not right now, but
Yeah.
I mean that is very topical and
Mm-hmm.
maybe possible.
That's great. Yeah. I love that. As we wrap, I mean, like I said, I'm just kind of going through it, and I think, but as we wrap up with discussion,
You could put that on the
yeah,
parking lot, as they're called, or something.
on the parking lot. Thank you. Yeah.
Come up with, other kinds of things to discuss at the end.
Good. Perfect. I love that idea. And then, of course, how do you actually implement this kind of thing? How do you recruit? How do you store the equipment? How do you train people to do it? How do you use data storage? Again, I think that there's a gradient here from very easy to do, maybe Pokemon Go plus one monitor of something in the environment, to something that's truly a human as probe sort of approach to measuring all of the different things going on the street. And so coming back to this, we can start to build a list of all the different kinds of ways we can collect those data. And where does that lead? Well, it leads to basically as complex as you want it to be, but of a matrix of a time and a space for a particular person, iterating through every one that you can get in your program, and then a vector of different inputs, of different environmental data and mobility data. And this could be with, I don't know if it's 5 devices. I mean, well, I'll tell you what I'm doing at Tyson's here in a second, but, without too much trouble, you could have a very dense vector of different kinds of data about the environment that may tell you something either that you want to know or that you didn't know. And certainly in some of the conversations I've had, it's how do we actually use machine learning to understand what this all means? And I think that's fascinating. That's not the area that I come from. But at the same time, to characterize our cities, our neighborhoods, our streets in terms of a vector, a diverse vector of data that we didn't have access to before. And that's essentially the idea. And that there's multiple ways of tracking that. First of all, do we need the whole matrix? I started talking about that. Well, if we're interested in recreational walkability, we might just want to know where people are going and how fast, measuring nature somehow, how loud it is, the temperature, and whether it's polluted. If we want to measure utilitarian walking, we want to measure how easy it is to go shopping. So this is walk score, for those of you who've heard of this, for example, but doing this with wearable sensing. We may want to be able to count people, tracks, and land use data that is actually secondary data. Because honestly, you don't need, unless you have really poor mapping, maybe there's parts of the world where we don't know what businesses are what, or something like that. But we have good directories of business locations generally and land uses. So combining those things to answer a question. And then finally, we're here. This is the climax, I suppose, so to speak. Then you walk around. I mean, ultimately, the idea is that you have people either on set paths, if you're doing it in the form of research, or if you're doing it in the form of crowdsourcing, you just have people going on their daily routes, building up the data set. And that's it. That's the whole thing. You can see kind of here, walking through different environments, walking indoors and outdoors. This is an iteration of the process where they had to use a phone once in a while to collect some data. So you could see the hand sticking out there periodically on the wearable camera. But that's it. That's the process. I think this is, oh, yeah. Yeah, there was a rug sale. Yeah, carpet sale, tent sale. And parking lots, lots of parking lots back in the mall. You know, that's the funny thing. I mean, often planners are very down on malls, but they're very comfortable and they're very accessible. It's just that you have to drive to them and then park. So, all right, that's enough of that. Let's see here. And so these are examples from one trip. So you get temperature measurements. And trying to remember, is this one a relative temperature measurement? This is an image I constructed a while ago. No, so ignore it. Ignore it. I think it's actually absolute temperature values, not relative temperature values. But then we have brightness, which is highly correlated with temperature, by the way. So we see the streets that are very bright and glary, and the streets that actually are a little bit more shaded, which often could be correlated with nature, or at least good street furniture, for example. Green channels. So there's this green channel measurement, which, using ground truthing was impressively correlated with the presence of trees in Tyson's Corner. So I was impressed with that it actually seems to work. And then, of course, noise. This wasn't in Tyson's Corner, just to show you a single path, how noise varies. And if you use noise tube, you would see the same kind of thing. Now, how do you put it all together? How do you analyze it? Well, this happens to be what I'm doing. I think ultimately, the more you want this to be usable, the more this all needs to be on a server and easy to do, and everything is spit out at the end. However, it becomes less engaging the more you do that too. And you have to find a sweet spot where people feel like they're actually doing something and learning something and receiving benefits. Now, Fitbits are very easy to use, so that, I guess you do want it to be easy. And, but then at the same time, to keep it low cost, you may need to use some more basic approaches. What I do is I get my sensor data from my multiple platforms, and right now they're not integrated. So they all have their own CSV, their own comma-separated value files that they spit out, or different KML files, all different kinds of formats, everything like that. They all, by my users, who are in this stage students, they all upload them to a single location. Either they self-upload or they do it themselves. But then I use R to pull them off of my cloud source, to clean them, aggregate the data, begin an analysis process, which then overlaps with ArcGIS. So that's what I'm doing right now. Ultimately, you would want this all to be seamless. What you see there is kind of the research process that I'm using right now. And there's a lot of important things to think about when you're doing the analysis. Certainly, I talked about automation really being key, and the trade-offs with that. But I think that in terms of analytic methods, aggregation, how we aggregate, is critical. I'm using a 10-meter grid because I found that it seems to be, just looking at the precision of my data points. I have both wrist GPS and smartphone GPS, so I can kind of compare them. And I use the wrist GPS because it's much more reliable. But so I almost always append the wrist GPS to the data points that came with the smartphone GPS. It's a complex process, I guess, is what I should say. And then how often do you need a data point? All of those things come into the calculation. And your units of analysis are multiple, depending on what you want to know. Do you want to know what an individual did and what they experienced as they went along their path? Do you want to know what a group of individuals is experiencing? Or do you want to know something about the location? The people are just probes, and you don't care really about the mobility side as much as you care about what the environment is going on in the environment. So those are all the kinds of things, and it leads to, this is student mobility. So this is about 15 journeys through Tyson's Corner, overlapped, one on top of the other. So you should take that as, when I say a mean, it's a mean of 15 values. It would be better to have 100, it would be better to have 1,000. But I have seen that as you add it in, it starts to, the uncertainty starts to shrink a lot. The variability starts to shrink a lot of the actual mean with every data point added. But there's real data here, and it's really fascinating, and it's data that has never existed before, or there's information that has never existed before from this. So that alone is kind of the payoff in some ways. So as it turns out, maybe we knew this implicitly, but we can measure it and show it. Being near the Capitol Beltway, the 495, is dirty. And so Tyson's Corner, while the planning for Tyson's Corner has a lot of walkability invested by the mall, by different places, kind of right around here, it's actually quite dirty there in terms of particulate matter because it's right near the freeway. Now this is true the world over, but we can see it and we can measure it. And it was all done in this case, it was done with this device, right? It was done with this device. And you can see where other major roads have high levels of pollution and the roads that are quite clean, so to speak, on average over time. Here's another one, which is noise. And not surprisingly, we find that the major roads are a lot louder than the minor roads, for example. And ultimately, I was trying to do this before we met. I was, ultimately, I keep getting more data in all the time. And essentially, then you decide how you come to a conclusion, how you do it. So my aggregation of multiple streams, temperature, nature, pollution, noise, you can bring it all together and come up with a value. This is very simplistic kind of weighting to understand, where are the places that may be more or less walkable. But you have it at a resolution that is quite unusual. And so anyway, I think that, that's basically what I have to say about it. I would say that, I'm glad to have had the opportunity to kind of introduce it. I had an exercise that I thought we would do. I think actually we can broaden it out a little bit if you think that makes sense. And just, spend a little time thinking about how would you use this? Or do you see a way to integrate this with something like Pokemon Go? I'd be really interested to hear what you all think. Yeah.
Facebook reactions.
Facebook what?
Reactions.
Facebook reactions.
Like, angry
Yeah.
Emojis?
Are those actually geolocated? And it just shows my lack of knowledge of Facebook. They, so actually, you know, something that is important about that is that it's not just, it's land use data because it's about a place, right? But then it has a quality that you wouldn't be able to get without a kind of a human assessment of that place. So that's very interesting. Yeah, Emily.
I'm wondering if before we go into this, maybe we should have people introduce themselves and
Oh,
like why they're here, you know, because some people I think are interested in this topic and like we're hoping that we were going to talk about blank or so I mean I think
great. Thank you.
sharing that might be helpful.
Sure.
I mean, again, if you're here because it's the workshop and I'm here, then that's a perfectly good response also. But I think we might get something from
Good. Thanks, Emily. That's great.
So yeah, I'm Emily. I'm here because the workshop's here. But yeah, I'm eager to sort of get your feel for why other folks are here.
Good. All right. Well, let's do it.
I'm Mati Abbas, I'm a engineer tech, and I'm here, I came all the way for the workshop.
Yeah.
Oh, okay.
You showed up for this.
All right. Well, good. Well, we have to, figure that.
So
Great.
what
Great.
were you expecting? Yeah. So tell us.
What were you thinking?
I mean, I'm interested in a lot of things,
Yeah.
in control in general, and driver behavior and driver flow theory.
Mm-hmm.
And in app development, and actually also game development,
Mm-hmm.
5 games already for education development.
Wonderful.
Used for classes. So the whole issue of integrating wearables into transportation solutions is
Yeah. Well, good.
We're losing our Delaware folks.
Yeah.
You guys are.
Time to go. Yeah. Well, good. Okay. Good. Good.
I'm Teresa Culver. I'm faculty member in Civil Environmental Engineering here at UVA. I actually have a joint project that Andrew is on, and he's, when I knew that the possibility of using wearables was involved in that. And so even though I'm an environmental person, I wanted to learn more about that. And actually, this has given me some interesting ideas. I teach the Intro to Environmental Engineering Laboratory class, and we are very interested in our department in getting more sensor technology to students. So it's made me think about how I can try to integrate it into our labs.
Great.
I'm Leah, and I'm a graduate student in EA, and I work with Andrew on a lot of the projects that he's looking at, including talking about this wearables for Tyson's, and actually did a study on Tyson's field last year. So also, this is where the workshop is.
Exactly. All right. Well, good. Yeah. Cody. Yeah.
Cody Fleming, faculty member and systems engineering here. I was just more interested in the topic from like personal societal
Mm-hmm.
standpoint. This isn't really my area.
Sure.
But it's an important topic.
Great. Yeah. Thanks.
I'm gonna have to cut out in a second.
Oh, okay. Well, yeah. Okay. Thanks. Yeah.
So on and like
Sometimes it's turned on, sometimes it's not. Mine works.
yeah.
Oh, there you go.
we had to-
Do you want me to throw the microphone up to you?
We'll keep going with at least with the introductions and why you're at the workshop. Yeah.
Graduate student at ODU. I work with Dr. Chetin and Dr. Paliti, and we do the data analysis, micro simulations, these kind of things. And this was interesting for me because most of our data analysis research are based on the data that we need more data, and we have to collect more data. So if we want to calibrate a simulation, we need data. If we want to make, I don't know, discrete choice modeling,
Yeah.
this kind of.
No, well, that's really interesting, and we'll keep going with the introductions, but I think, yeah, as much as this is to answer questions just in terms of existing conditions, but also predictive, I think there's both opportunities with these streams. Yeah.
I'm Ehsan, and I'm a graduate student in ODU, and well, I came to see what possibilities there are for wearable sensing
Mm-hmm.
and how they link to sustainable transport decisions.
Good. Well, yeah. Now you know, maybe.
My name is Elena. I'm a graduate student from Old Dominion University, and I was just curious in the subject.
Great, great.
My name is Olcay Sahin. I'm a PhD student at Old Dominion University, Civil and Environment Engineering. I'm interested in the topic very much because this is my research area.
Oh,
So
okay.
I'm in the mobile sensors. Currently, we have an app that we're constantly collecting data
Mhm.
with the app. And thanks God that most of the research is just using the data that we are collecting. So I just curious about I never go into the wearable sensors yet.
Mhm.
So this is interesting to me.
That's great. Very good. Good. Okay. Well, okay, Beth. Yeah.
I'm Beth O'Donnell from UVA, and I was interested to figure out what Andrew's all about, and we're always looking for new training topics, so thank
Well,
you.
good. Good.
I'm Hyun Lee, and I'm a PhD student in transportation planning at Virginia Tech. I'm here because I'm interested in mobile sensing too. I'm gonna be working on a project using a mobile app and track people's route and mode choice, as well as another students tracking people's mood when they're traveling. So I think it has some overlap here.
That's great.
It's
So you're doing
interesting.
it on the perception and emotion side. I mean,
Yes.
with tracking,
Right.
geolocated and
Yeah.
fantastic.
Yeah. So yeah, I'm interested in mappiness app as well.
Mhm.
Never used that, never heard of that, but yeah, definitely interesting.
Check it out, definitely. And there's some papers on it, so yeah, yeah. Well, good. So, well, it's a good group. I'd like to then, maybe we can do an exercise. We're such a small group anyway. I kind of feel like we should just talk a little bit. I really feel like that's, to kind of wrap this all up. I'm really interested in really any of your thoughts about the feasibility of this, but also my perspective on it is a particular perspective, and I'd like to hear your perspective on this in terms of what the major friction points are in implementing this, the usefulness of this, how you've been thinking about it. I'd love to get a conversation going with,
We have like a 6-minute break or something.
Do you want a break?
For sure come back.
Well, will you come back if there's a break? That's what I'm worried about. What? What do you think we should, if we have a break, won't it be over then? That's what I'm worried about. I think we should just have, let's say we wrap at 2:25, but if we want to have, I'm not going to go anywhere. So I'd love to, if there's some detailed conversations, we should do it. But let's just have discussion. This is the length of a typical class now, basically. That's what I was kind of hoping for, is we could get it in half. So I think we did it. We did it. We cut it in half. So yeah, please. I'm really curious how you all, some of you have been working deeply on it, and some of you are coming at it at fresh. What are your perspectives on it? And have I hit on anything that you've been thinking about?
Yeah, I guess I'm interested, so for the perception stuff, is it so you have an app that is able to, how do you figure out perception? I sort of understand, collecting noise or, collecting video, so I'm curious on perception.
Yeah, what we are planning to do is we are submitting for IRB approval right now, but the app that we are using is the one, because I'm working with Steve Hankey, and he's working with Yingling Fan, professor at Minnesota, where she developed an app which it popped up after every trip, because it can detect the trip, and it popped up the message. Basically, the question will be coded into that, and it popped up the question asking how you're feeling right now, and then we have a scale, say, extremely unhappy versus extremely happy, and extremely tired versus extremely, say, I don't know.
So this is that difficult friction where the person has to do some kind
Right.
of work.
They have to do the job. They have to do a lot of work because I know they have to do that every day for like 1 or 2 weeks. And again, it's really hard to make people really do that and collect reliable data.
Yeah.
Well, I guess all of graduate students at some point have to do data analysis and they need data.
Mm-hmm.
And most of us, I think, we are collecting data somewhere. But the thing is, whenever you ask somebody to do, I don't know, if you feel relaxed, you feel happy, but when you ask somebody about that, you affect the
Yes,
and
you do.
for our case, when we collect data in the tunnel, we use OJ's app to collect our driving behavior data. When we are collecting those data, we are actually affecting the data because we know
Yeah.
that we want to use this data. So I always want to think about how to collect data indirectly.
Mm-hmm.
Something like if we use Pokemon Go or a game or
Yeah.
something like that
Yeah.
to use data that would be much, much richer data.
Mm-hmm.
So I think we have to come up with some kind of startups or some kind of things that involve people
Yeah.
in some sense to collect indirect data, like Facebook collects marketing data
Mm-hmm.
indirectly.
Absolutely. Well, I think it's an interesting problem, and it's an important problem in this whole field, and so the research question that you have with Yingling Fan is it Yingling Fan? Okay. Yeah. Yes, because I'm aware of the Minnesota project. It is problematic. Now, I think you're right. I think that today we have a whole set of, like you called it, indirect approaches. I think a good environmental psychological study always has to find ways of not interfering with the actual experience. So there's a couple of approaches. One is, again, it's stated preference, I shouldn't use that terminology from travel surveys, but I think it's a statement about an emotional state. May or may not be true. I mean, there's some really interesting research on Facebook about whether people are telling the truth about how they feel. But I've used Yelp data for just that reason, to look at how people feel about how they got to a restaurant. And it's really fascinating. It's really interesting. The other side that, I didn't put in here, and it just, I didn't think about it. I'm not using it, but I have some colleagues who are. There's such a thing as an EEG cap, an electroencephalogram hat that measures your stress levels when you're doing that. So that, may be something you've explored or could explore. These things are very emergent. So it depends what your objectives are with your data analysis. Are you trying to prove it works, or are you trying to actually answer a question with the data you've collected? This is a huge issue with all of this. Are we still proving the system, or are we actually starting to be able to answer questions? Yeah.
Yeah, it's an interesting point. Collecting is a problem of measurement, because when you directly measure that, yes, you somehow intervene the process, and maybe they affect the answer. But also for travel behavior, I think indirectly measure through Facebook kind of probably hard. Not to mention that from a social psychology standpoint, if you tell something to a lot of people, say you throw something on Facebook or Twitter, a lot of people are gonna read that. It's more likely you exaggerate thing, or if it's somehow, it's not reflect the truth. As opposed to you carry something and you just tell the researchers like, no, I'm not happy about this trip, and I don't feel relaxed. So yeah, it really depends on the context and your research question. But yeah, I think that's a good kind of data to collect Twitter, Facebook.
Absolutely, yeah. I don't know, what else have you potentially thought about using? Tell me about your research with kind of sensor data, or even whether it's wearable or not. Anyone else? Olte, great.
Yeah, so we are, using the sensor data which we collect from the smartphones in different fields, such as one of our project is my colleague is working on that, estimating the speed.
Yeah.
Without estimating the speed, vehicle speed, without using any GPS or OBD data. Just the accelerometer and the gyroscope data, which
right, yeah.
which
Is there a poster that?
There's not a poster actually.
But I think you guys did a sustainability conference poster a year ago, right?
Yes, it
Oh,
was,
okay.
it was one.
So the TRD sustainability.
Oh, okay. Sorry. But just using those. Yeah. Mm-hmm.
The so since our smartphones, or just regardless of your choice or not, they always running the sensors background. It's just not recording the data.
Mm-hmm.
What the app we developed is just not recording the data, but not you should just start collecting data. The problem is you mentioned it about just not to put the information just in the starting, or just not controlling the app with the person is very hard.
Mm-hmm.
So it should be some automated, like every time should be the collector, but this time is draining.
Yeah.
Battery draining issue is just a problem.
Yeah.
And the second research, again, another my colleagues just working on the same data, exact same data, direction identification, and the turn identification.
Mm-hmm.
So where did you turn? Like to the south, north, but this needs to be a little bit help with the GPS. But without using GPS, we can understand is a turn or true direction.
Interesting.
Yeah. So this is another research.
Do you think that? So that's in vehicular motion, right?
In vehicular motion, yes.
Do you think people are too slow for any of that to work? Like if you were on a bicycle, or even more, if you were in a car, you were walking and you walked into a building, would it continue to function?
Yes,
Oh.
it's continue to function. But this actually this is the time dependent. It could be you can identify the turn, but in terms of accelerometer, the speed is hard to find it.
Yeah.
But
Yeah.
the turn or true
You can find
point,
that.
you can identify that.
Very interesting. Very good.
It collects the every direction. So you get the up and down, left, right.
Yeah.
Just constantly collecting.
Yeah. Absolutely. Great. Well, I'm sorry I forgot your name, but our visitor in front from VTT. Mati. Yeah. So what kinds of work are you doing, or related to sensing, wearable sensors?
Really, environment behavior research.
Ah.
Control aspect that correspond to the
Mm-hmm.
Samantha, can you make your mic go?
Where is the mic?
Push that little button. Talking.
Mm-hmm.
There you go. There is
Yeah.
a sensor right here.
Yeah.
The thing that came to mind when I was listening to you is that there is a need for a portal and a common framework that could be the target or the attraction for many researchers that can come in and contribute.
Yeah.
And then we could be amazed by how many people have related research that could be integrated together. So
yeah.
just as an example, you know, one of the research that we have done was the effect of emotions on the driving behavior.
Mm.
So if you know, you know, from your app that I was not aware about, or some of the apps that were mentioned here, if that could be looked at in a network-wide, and then you can know the different kind of change in behavior about how people can drive and how does that impact the overall network performance, and that could also feed to people who are working on traffic management and control, and people who are working on prediction of traffic patterns and all of that. You know, things can come together much faster.
That's
So-
really interesting, and it almost calls for like a standard on naturalistic behavior and environmental data that you could, you know, you won't necessarily collect everything, but it fits into a framework, and location and time are part of it. Oh, that's really interesting. Yeah, no, I think you're right. Yeah.
So my curiosity, so the people that are working with
Oh yeah, it's almost
the
2:30.
apps, I'm sorry, so
Yeah.
people that are working with the apps, have you had like battery drain problems, like, you know, with the Minnesota like thing coming up? Because that, you know, I guess the few things that we've done here at UVA, it's been this huge headache, as Brian Smith was talking about.
Yeah, it's really a problem. When I was thinking about, before I came up, we really go into this project, I was thinking like if you use a real GPS device, is still like have battery problem as well. It's harder for people to charge GPS on the regular basis as opposed to they use a smartphone themselves because they have to charge them anyway. The good thing about that app is like at least they advertise that it consume not so much battery and data. So if you're not enrolled in a, you know, mobile plan or something, if you pay as you go, for example, it doesn't consume a lot of data anyway. So I think they calculated like 90% of mobile phone out there, smartphone out there, can use the app run on the background for 8 hours or more. So I think it's pretty good.
So what about the ODU apps?
Our app, so it is very advanced, kind of advanced app because we're connecting like with the OBD, the Bluetooth, via Bluetooth, and the GPS is on, and all the sensors are keep recording.
Yeah.
If you don't turn on GPS and Bluetooth, there's no problem.
Yeah.
It just goes all day. But no, when we turn it on, the GPS, it gets the data per second data, so it's always not a connect. But if we set the GPS per minute, it's not that much time consuming. The drain battery. Since we have we set this the frequency of GPS connection. If it is very short this time, it's draining, but otherwise no.
So I'm sorry, I'm just my questions. So now, back to Reza's point of, you know, the more we could figure out like how to add on to something people are already doing, like sort of the better.
Yeah.
So the two things I like have come up with, and maybe you guys have additional ideas, which would be great. So the Pokemon Go, like, sounds like, you know, people are wandering out there, going different places, you know, wandering into streams and finding bodies, right, or whatever. So you know, that sounds like an ideal to me, or, you know, definitely going into places they don't normally go. But even, you know, I think what Huyen was saying, you know, when your phone says, like, you know, I start driving, they're like, okay, you're now 23 minutes from home, traffic is normal. Like, so if there's a way to like tag on to that, you know, yes, you're moving, you know, you're on a trip now. I mean, I think the hard part is the phone, or definitely at least my phone, picks up when I'm in my car and traveling. Like, I think you were asking, is it picking up on my, you know, walking trips? And yeah, I mean, I don't think it is. So, but maybe if I was a commuter every day, would it like say something about commuting? But I guess, but maybe the difference too with commute, like a walk commute, is that there's probably not much like time differential. It's like, you know, okay, you're 12 minutes from home. Like, you're always 12 minutes from, you know, so, but I mean, and maybe you guys have other ideas of, you know, something that people are already doing, or that our phone's already telling us is, you know, a trip or something, and then, like, if there's a way to add on to that.
Well, what I will say, I mean, I think it's really interesting, and just briefly, this is a huge issue, and it's, you know, it extends beyond mobility research by far. There's a group that, you know, is very much a kind of Silicon Valley style group, but called what are they called? CrowdSignal.io. And I think they are developing protocols to collect smartphone data in multiple dimensions, all of the streams of the smartphone, in a regularized kind of way, and share that data with researchers. And I think we have to think, I mean, I encourage you to look at it, you know, look at it and see if you want to participate. I think for $10 you can get their data. So, you know, that might be very interesting if you're looking for data analysis projects. But I think that what's possible with the smartphone can it be done in a regularized way, and who can you get to do it? So I think the thing about the Pokemon Go game is that, you know, everyone is doing it, but who would be willing to contribute their data is a much smaller set. And especially if it's integrated with some other kind of sensing technology, it shrinks even more. And so just so you know, what they've decided to do is they say, well, we have to pay people. There's no other way to do this research with wearable sensors, but to treat it like any old-fashioned research study and give incentives. Like they cannot think of any other way. And I think it's a sobering, to say the least, that, you know, getting participation is the economic way, paying people for their time and their data. Yeah.
I also know another the group developed by New York Times, and they called OpenPath.
Oh, I haven't.
Yeah, they also have similar. So
that's interesting. There's multiple groups.
Yeah. So I mean, you can just let the app turn on, then just collects your GPS data.
Okay, so they're doing GPS. This one, if you go in, it's everything, and I'm actually really interested in it, and I you know, some of you may be as well, because it shows what apps people are using when and where, and I think for mobility, that's actually kind of like, when do people turn on Google Maps, when do they not use it, when do they use Facebook or whatever. I think that's actually kind of, and when and where, that could be really interesting. But anyway, it's after 2:30, and I promised, I'm not going anywhere, so I would, you know, as much as we want to talk or talk offline later, please do, because I really think this is an interesting area, and we've kind of down to our core group here of people who have some interest. This was just kind of my thinking about it and kind of my efforts to create one that both uses location and mobility data plus environmental data, and is there a way of doing that? But I think I've heard from all of you that there's a number of ways of doing this, and not just a number of ways, but a number of data streams that we might use, questions that we might answer. So I think this will continue to grow and expand. All right, well, thank you all very much. We cut it in half. It's not 4 o'clock, it's 2:35. So thank you for coming, I appreciate it. Great, good. All right, yeah, so hang out. I don't know what's left. This is the true end of the,
This is the true end.
yeah, exactly.